Hello? Can you hear me, guys? Hello? Can you hear me? Oh, is it loud enough for the people in the back? Okay, good. So welcome back to Intro to Statistics. And so if you did not get a copy of the lecture notes I gave of this stuff, if you did not get a copy of this on Tuesday, please come forward at the end of this lecture today, all right, and collect a copy of it, right? Okay. Now, a couple of announcements. Number one is about the lab sessions and the tutorial sessions. I mean, some of you send me emails saying that you have a clash. If you have a clash, you can come to one of the other ones. There are 5 slots. You can choose one of the remaining 4 slots, but you should try to stick to it, right? Please stick to one of the 4 remaining slots, right, in the future. That is, if you do have a clash, right? And if you have some important appointments, like doctor's appointment or something, then, and you happen to miss the lab session or the tutorial session, then you can choose an alternative. But make sure that you don't have too many appointments. I mean, doctor's appointment is okay, right? But like, I wouldn't consider every appointment so important. Like, for example, an appointment with your girlfriend or boyfriend. That's not so important, right? Or is it? Come on, guys. I'm trying to just make jokes, guys. Yeah. Anyway, now I sent you guys a Zoom email yesterday, right? Did you all get it? Like, I'm disappointed that nobody wants to Zoom me. Why is that? I mean, you can Zoom me anytime, man. Wherever you are, you can try to Zoom me and try to talk to me. I like talking to students. I like having chats with students. I mean, you can talk to me about anything you like, okay? Okay? So I mean, I keep my Zoom open 24/7 even when I'm asleep. So you can ring me 24/7. Okay. All right, guys. Shh. So here we are. This is. I want to quickly go through the stuff that I did on Tuesday, and then I will do some more stuff. All right. So this is stuff I talked about. This is just general stuff, right? I talked about on Tuesday. And the lab sessions this week are on the software called R, which is a free statistical software, and you can download it from this this page, right? And you can download it to your laptops or iPhone or iPad and play around with it whenever you have time. Okay, and I mean, R is really important, especially when you go into the second and third years. R is going to become increasingly more important. And also, when you start looking for jobs or higher studies, I mean, they look for R. So R is really important. So please make sure you learn it. Any questions about R, you can email me or Zoom me 24/7. Right? That's why I have this Zoom. Right? All right. The one thing I said yesterday on Tuesday was that the material that is examinable for this course is everything that I write down on this visualizer. So as far as the exams are concerned, the only thing you need to focus is the stuff I write down here. All right. And this is just definition of statistics. Right, definition of statistics. I talked about it. These are popular trends in statistics, 4 big areas: big data, deep learning, machine learning, and bioinformatics. And there are 4 elements of statistics: the population, the sample, the parameter, and the estimate. Right, and these are the notation common. Capital sigma, S, theta, capital theta, and theta hat. This is example 1 on the 4 elements. Example 2 on the 4 elements. Right? And there are 2 kinds of sampling. I'm sure you know this from probability 1. Sampling with replacement and sampling without replacement. Right? Okay. SRS stands for simple random sampling. And this is an example I did where I'm talking about sampling with replacement. And this is another example I did where we talk about sampling without replacement. So this is stuff we did, right? All right, so this is all the stuff we did on Tuesday. By the way, you don't need to copy any of the stuff I write down here because as you saw, like after every lecture, I scan the material and put it in the course website, right? Do you guys know where the course website is? Don't tell me you don't know. I do not use Blackboard, right? I mean, that should be a big relief for you because Blackboard, I think, is the waste of time and money. I mean, I showed you what the course website is on Tuesday. Did you write that down or no? The course website, if you don't know where it is, this thing here, this is the course. This is the course website, right? So anything you need to know about the course, you just get into this page. That's all you need to do. And this is not password protected, so you can just get in without typing and log in or username or password, right? All right, guys. All right. Now today I'm gonna continue from what I talked about on Tuesday. All right, variables. I'm sure you heard about variables in probability 1, right? There are two types of variables. One is called qualitative variables. When I say qualitative, it's about the quality. It refers to the quality. So, for example, color, right, or gender, or pass fail. These are all qualitative variables, right? So each of these refers to a quality. And there are also something called the quantitative variables. All right, the quantitative variables, there are two types of quantitative variables. One is called discrete. There are discrete quantitative variables and continuous quantitative variables. So when I say discrete, examples could include, like, say, number of accidents, or number of floods, for example. I mean, in this region we have so many floods. So, and these are discrete random variables. And there are also continuous random variables. So, for example, continuous random variables could be height, weight, right, and so on. So these are examples of continuous random variables. I'm sure you saw much of this in probability 1. Okay. So the next, in this course, I'm going to focus more on the quantitative random variables. So they can be either discrete or continuous, right? So let me put this over here. Hopefully you can see this. Just copying it down. You can see this. Right. So I'm going to focus on quantitative random variables. So now if if X is RV stands for random variable, okay? I'm sure you know that. If X is a random variable, then all right. Okay, if X is a discrete random variable, by the way, then this is the definition of the probability mass function. I'm sure you've seen this in probability 1, right? Whereas you guys okay? If X is a continuous random variable, then right, guys? Can you read my writing, guys, from the back? Yes? Good, good. Oh, yeah. Happy to hear that. So if X is a continuous random variable, then this guy here, which is denoted by little f of X, is known as the probability density function, or the PDF of X, right? The next thing I need to define is right. If X is any random variable, discrete or continuous, this is the definition of the CDF, or the cumulative distribution function of X, right? Right? You guys okay? Let me put this over here. The next thing I'm going to talk about is, any questions you have, just feel free to ask me. I know this is a big audience, but I mean, I like to talk to every one of you in person. I like to engage with every single one of you on a one-to-one basis. That's the style of my teaching. So I would appreciate any questions. Just feel free to ask me. All right. Right, now if you have a variable x, right, the E of x is the population mean, or it's also known as the expectation, right? And the variance of x, which is defined by this, is the population it's known as the population variance. Okay. And ST stands for standard deviation and is defined as this positive square root of the variance, right? And it's known as the population standard standard deviation, right? And finally, the nth moment, which is defined as where n is a positive integer. This is known as the nth moment of x, right? So for example, if n is 1, you have the expectation or the population mean, right? When n is 2, you have the expectation of x power 2, right? And so on, okay? All right, guys. Okay, the next thing I'm going to talk about is independence. Independence of events and random variables, right? I'm sure you learned about this in probability 1. Yeah, but some of what I'm saying may be same as what you learned, right? So if you have two events, A I'm sure you know this from your A level, right? If you have two events, they are independent if the probability of the intersection is equal to the product of the probabilities, right? And if you have n events, not just two, but n events, if the probability of the intersection of the n events is equal to the product of the probabilities. I'm sure you know this, right? Or don't you? That if you have n events. Okay. Now the question is, how do you define independence of random variable? I mean, these two are, I'm sure all of you know, but how do you define that two random variables are independent? So that's what I'm going to talk about now. Put this over here. So continuing, right? Suppose you have two variables, say x1 and x2. Okay, so here we are talking about random variables, not sets, right? Sets and random variables, they are not the same thing. Okay? Okay, now they are independent if all right? All right? So two random variables are independent if the probability of the joint event that x1 is less than equal to x1, x2 less than equal to x2 is equal to the product of these two probabilities. Okay? You guys okay? And similarly, if you have n events, so suppose so if you have n random variables, x1 to xn, then the same thing happens, right? So they are independent if the probability of this joint event, right, is equal to equal to this, right? All right, so this is the definition. This is the condition that you need to check to make sure that the random variables x1 to xn are independent. All right? Any questions so far, guys? Okay, right. The next one I'm going to talk about is a random sample. Okay, you might have heard about this term before, a random sample, right? Right? So you say that a sequence of random variables x1 to xn is a random sample if they are independent, right? If they are independent random variables and also they have the same distribution. In other words, their CDFs, you know what a CDF is, cumulative distribution function, are identical. So the CDF of x1 is the same as the CDF of x2 and all the way up to the CDF of xn. They are all identical, right? So in that case, this sequence is known as a random sample. Okay? All right, guys. Next one. All right, just one announcement. The quiz 1 is due next Tuesday by 9 a.m., right? So I would like you to submit I will not accept any submissions after 9 a.m. Tuesday, right? You follow that, okay? I will, if you are a DAS student, I mean, if you are a DASS student, then I will give you additional 30 minutes. So instead of 9 a.m., you can submit before 9:30 a.m., right? That is if you are a DAS student, right? Okay? And you will get the results of your quiz on the same day, on the same day, that is Tuesday, 4th of February, okay? Hello guys, you okay? Right, if you have a random sample x1 to xn, right, then the sample mean is denoted by this formula, right, which is x bar. X bar is the notation for sample mean, and is defined as 1 over n times the sum of xi, I from 1 to n. The sample variance is denoted by the following. Well, there are actually two formulas. I will write down two formulas. They're slightly different. So it's denoted by, this is the notation, S squared, right? The notation for sample variance. And there's another definition, which is instead of n, it has a n minus 1 in the bottom, right? I will explain why in a minute. So both these are used in statistics, this formula or this formula, right? And the first formula is known as a it's known as a bias version. I haven't talked about bias yet. I mean, it will take a few more weeks before I talk about bias. But until then, just please be patient, right? I will explain what a bias is in maybe like 2-3 weeks' times, right? And this is known as unbiased version. Okay, guys. So there are two formulas. So there's a slight difference. One has n in the denominator. The other has n minus 1 in the denominator. So if n is a very large number, say 1,000 for example, they will be almost the same, right? Okay. The next one is oh. Okay. Shh. Come on, guys. Yeah. The next thing I'm going to talk about is mean and variance of x bar, right? Now, I already said what x bar is. The x bar is defined by this, right? So to find the mean and the variance of x bar, right? This is, you just need to, to find the mean of anything, you need to take the expectation. Remember, expectation is the same as the mean, as I said in a few slides ago. It's the population mean. So it's equal to this, which is equal to 1 over n. You can take the expectation inside. Right, is equal to this, okay? And because the expectation of xi, because we are assuming x1 to xn is a random sample, right? So basically what you have here is expectation of x1 to the expectation of xn. And each of these random variables have the same distribution. In other words, they have the same CDF. So therefore, the expectations must be the same, right? So let me call this guy here mu, right? I'm just calling it a name. You can call it any other name you like. So I'm calling this guy here mu, right? So every element within the square brackets must be equal to mu, because x1 to xn, each of them has the same distribution, yeah, by the definition of random sample, right? So what you have is 1 over n times n mu, which is equal to mu, right? Okay, where mu is the expectation of x1, the same as up to the expectation of xn. Okay, mu is the common expectation of the n random variables. Okay, so this is how you find the mean or the population mean of the sample mean, right? Okay, is that clear, guys, or not? Or are you lost already? Don't tell me you're lost, are you? Okay, the next thing is the variance. The variance of x bar is as follows. All right, so you're going to take the variance of this guy here. Now we know that x1 to xn are independent variables. So when you take the variance inside a sum of independent random variables, I don't know whether you did this in probability 1. Some of you say you didn't like probability 1. I hope you like this. Yeah? Okay, so this becomes this, because that's the property of, like, if you have independent random variables, yeah, and you take the sum of them, then the variance of the sum is the same as the sum of the variances. Do you know that property or not? Yes, all of you? Okay, so what you have is, and the n here becomes n squared. I'm sure you know that. Like, if you have a constant, when you pull it outside the variance, you need to square it. I mean, these are the kind of, I mean, if you have problems with this, you really need to Zoom me, guys. All right, so this is what you have. All right, now because x1 to xn, they all have the same distribution, each of these guys here must be the same. So let me call this guy sigma squared, right? So every one of these elements inside the square brackets must be sigma squared. Okay? You with me? All right, so what you have is 1 over n squared multiplied by n times sigma squared, which is sigma squared divided by n, right? Where sigma squared equal to variance of x1 is the common variance. Okay. Are you with me or not? Hello, guys. You have any questions on this? You sure? All right. Now, before you go, there are 2 example classes this afternoon. So if you haven't been, if you are allocated to one of them, please do come. All right. And there's also 1 example class tomorrow, Friday at 11 to noon. Right. So please do come to that. If you haven't got a copy of this, any of you who hasn't got a copy of this, can you come forward, please, and collect one? Sorry, what's your question? Can you just give it like that?
Wie
Just a minute, sir. Hello. Hello. You're all right. You okay? Yeah.